What's going on, everyone? We've been talking about plots, histograms, bar charts in MATLAB. I've got an example here. We are conducting an experiment for which we bought 109-volt batteries from Amazon, measured their actual voltages, and now we're going to view the voltage distribution. Load in the data, use the histogram function, use the plot function to make a plot of the histogram bin heights in a separate figure. All right, we can do that. Notice here in my current working directory, the desktop, I have a data set, statistics exp for experiment .mat. So the first thing I'm going to do is load in that data set, statistics exp.mat. I think the .mat is optional. What that's going to do is it's going to load in a variable with data. So I'm not sure what that variable name is, so I'll just execute that command down here separately. And we see that that loads in voltages, which is 100 by 1. So that's got the 100 voltages contained in it. So I need to operate on this variable voltages. That's good to know. All right. So I'm just going to make a comment there. Load in, and then voltages is the name of the variable. All right. Well, what am I going to do with that? Right. Well, I need to make a histogram, so I will say histogram voltages, and that might be good. I might want to make a new figure before that, so this is optional. But if I had other figures hanging around, I would not want to overwrite those figures. So the fail-safe there is just to create a new figure. Create a new figure. Right. So this makes the histogram. All right, and I might also want to do some fancy things like turn the grid on, right? Give the the horizontal axis a label, like no, not x title, x label, voltages in volts, right? Y label. Maybe I'll say count, right? And then I'll say title. Notice you can put two commands on one line. You just have to have them separated by a semicolon. Title, I'll say example histogram. Okay, good. Now, the next thing I want to do is make a plot of the heights of the bars. So I need to ask the histogram function to return the heights. So I'm going to say h equals histogram, like that. Okay, that returns, if you remember from the last video, an object called h with fields, h values, and h bin edges. So I'm going to plot the bin edges versus the fields. So I'm going to create a new figure, right? Figure, and I'll just comment create a new figure because I don't want to overwrite the histogram figure, and I will say plot h dot bin edges. And if you don't recall that, I'll demonstrate that in a second. Why we're putting bin edges there, and then comma h dot bin values. Okay, that's good. Make a plot. Make a connected plot, right? It connects the data with a line, and then I also might want to give, the grid and the labels and everything. So I might say grid on, X label voltages, Y label we're going to say distribution. Okay, and we're going to call this example distribution. That's okay. And then this is actually going to give us an error, but I'm going to show you that error in a second. So I'm just going to save this, Control S, and I'm going to run it. And you'll see that we get an error here. No appropriate method, bin values. Oh, okay. So let's recall what H is. I'm just going to type H in the console, and you'll see H is a handle to deleted. Why is it deleted? That's odd. All right, all right, that's weird. So what I'm going to do here is type H there and leave off the semicolon so it echoes. Let me run it again. All right. So what we see here, I think it's deleted because I X'd out of the figure. But what we see here, H is a histogram object, and it has these properties, right? Data values. So we want the values. Those are the bin heights. So that is, I currently have it bin values, but I should just have it H dot values is what I need. And then you'll see bin edges is another property. So I've got H dot bin edges. So those are the X, a part of the coordinates, the horizontal, and then this is the vertical. But also something I want to point out here is that there are 9 values. So by default, this histogram function is making 9 bins. But bin edges, actually, if you counted them there, you'd see 10 numbers. And the reason there are 10 bin edges and only 9 bins is that there's a left and right, to each bin. So these are all like the left edge. That's the left edge of the first bin, left edge of the second bin, third, fourth, fifth, sixth, seven, eight, and 9. And then this because this is the 9th bin is the last bin, this is the right edge of the last bin. And so we're not going to use that. Remember, to plot, it has to be 1 to 1. They have to have the same length. So what I'm going to do here is say bin edges 1 to n minus 1. In other words, we're going to leave off the last bin edge, and then we should be good to go. All right, so this generated the figures. Let me show you which figures that generated. Let me dock these guys. All right, so here's our example histogram. Right, that looks pretty good. You can see that our 9-volt batteries fall, around 9 volts. Some of them are less than 9. Some of them are a little bit more than 9, but they're pretty much 9, right? So we get a kind of like a bell-shaped distribution there. And then our plot, here's the plot of the bin heights, right, versus the bin edges. So you can see, it's giving you the same information, just not as bins. It's giving you the information as a connected plot like this. And you can say, well, it's not, or it's got these corners to it. And that's true. That's just the way our data was. So, nothing we can do is going to prevent these sharp corners other than getting like more batteries. If we got like 1,000,000 batteries, you'd see there'd be like a smoother curve because we could have more bins then. But for our data set of just 100 batteries, this looks pretty good. And I am happy with that. So the last thing I would do here maybe is just save these figures as JPEGs and as .fig files in case I wanted to edit them later. And then I could put the JPEGs in a report if I was going to use these figures within a report. All right, thank you very much.